Perfect.
Yeah, so today we'll be discussing this paper uh, named Sparks of Artificial General Intelligence Early Experiments with GPT-4. So, the main idea behind discussing this paper is trying to gauge what are the current capabilities of GPT-4. And yeah, like with the size of these language models, large language models continuously increasing, what kind of behaviors can we expect, from even bigger models? So that is the whole idea behind this paper. So just a few note before we begin. So first thing is that this entire paper is the results presented in this paper are on an early non-multimodal version of GPT-4. So right now the GPT-4 is a multimodal model, but this paper particularly focuses on only text version of GPT-4, and also about how we'll be reading this paper. So since we're directly reading from the paper and not using a presentation, to make it easier to understand, like we can only just focus on the highlighted part. So that's the we'll be discussing more around about the green points here. Yeah.
Uh,
So
Akash, can you zoom the PDF a bit?
yeah, is this fine?
Yep.
Okay. So yeah, so the authors basically report their investigation on early version of GPT-4 when it was still in active deployment by OpenAI. So beyond its mastery of language, the authors have observed that GPT-4 can solve novel and difficult tasks that span mathematics, coding, vision, medicine, law, psychology, and more without needing any special prompting. So each of these fields we'll be checking one by one, and the authors claim that it could reasonably be viewed as an early yet incomplete version of an artificial general intelligence or an AGI system. So that is the abstract. So the paper is a very long paper. It's almost 92 pages of the main reading material, and it is spread in multiple sections where they discuss GPT-4's capability in different areas like multimodal and interdisciplinary composition, coding, mathematical abilities. So today we'll be covering till section 5, and next week Jay will continue from section 6. So yeah, so to introduce this, so whenever people discuss about AGI, they start with a definition of intelligence. Since there is not a single definition of intelligence out there, people first pick the definition of intelligence that they prefer, and then try to work on it. So different people have come up with different definitions of intelligence, like Marcus Hutter thinks of intelligence as the ability to solve a huge variety of problems in different environments. And yeah, Pai Wang thinks of intelligence as the ability to solve problems in a constrained resource setting. So yeah, and Francois Cholet thinks that the ability intelligence is basically the ability to rapidly gain new skills. So yeah, as you can see, there are a lot of possible definitions of intelligence. So to start with the discussion, the authors here have finalized their. They have defined intelligence as a very general mental capability that, among other things, involves the ability to reason, plan, solve problems, think abstractly, comprehend complex ideas, learn quickly, and learn from experience. So this is kind of like a very general definition of intelligence. And yeah, so basically they point out that over decades, AI research have pursued different principle of these of this intelligence definition that we just discussed. Like some people focused on reasoning, other focused on common sense and knowledge. Some people focused on planning by training their agents to train them to play chess or Go. And this has been going on for almost like 50 60 years, because people have been trying to create a general intelligence from quite some time, but the term AGI was popularized in the early 2000s to emphasize the aspiration of moving from narrow AI. So even not even today, maybe like 5 or 6 years ago, a lot of systems were very narrow in their results. So they will be very good in a particular domain, but they won't really be good in other domains. So like an algorithm that plays Go is not really good at natural language generation. So the aspiration to build an agent, which is much more smarter and is much more general when it comes to be able to solve different kinds of tasks, that was coined as the term AGI. And yeah, so the whole idea behind this paper is that they think that GPT-4 is showing some early signs of AGI, and we will be discussing about those capabilities in detail soon. In this paper, we report on the evidence that a new LLM developed by OpenAI, which is an early non-multimodal version of GPT-4, exhibits many traits of intelligence according to the 1994 definition, which we discussed here. So another key thing here is that they interacted with GPT-4 only using purely natural language queries. So they are basically interacting with the agent with text. So even if they are trying to ask it to do some, visual, give a visual output, the input they're trying to give and the output that they get is through language, which they later converted to image, which will be clear soon. And the authors claim that GPT-4 is a significant step towards AGI. Yeah. So a very common theme that you will see in this entire paper, we'll soon start discussing examples, and a very common theme that you will notice is that GPT-4 is converting information from one domain to another. If the conversion can be expressed in a single generation step, or what the authors will later call as a linear thinking step, GPT-4 is able to do it, which shows that GPT-4 knows how different concepts of different fields are interrelated. So let's begin discussing the example. So they ask basically, can you write a proof that there are infinitely many primes with every line that rhymes? So it's again here what they're trying to do is combine two areas, right? Poetry and mathematics. So basically GPT-4 is able to do it. And another example they gave is like try to draw a unicorn in ticks. And the GPT-4 was able to produce a latex code whose corresponding picture looks like it's not a unicorn, but you can see this horn, like you can see. So you can see that GPT-4 knows the idea behind what is a unicorn, and it knows how to express that kind of image in latex. So yeah, you'll be throughout this paper, you'll be surprised like how much does GPT-4 know already, and its ability to transform one sort of information from one particular domain to another one. It can also solve, maths problems step by step. So this particular question, even I took some time to understand and try to solve it myself. And basically, GPT-4 also solved it the same way, and it was much better at explaining it than me. And another theme that is common in this paper is that they try to compare how GPT-4 compares to ChatGPT, like because they have no other, very good system that is, very good at giving outputs to very general questions. So they compare GPT-4's performance with ChatGPT, and this way they can see how GPT-4 is better than ChatGPT. If you ask the same question to write a proof that there are infinitely many primes with every line that rhymes, ChatGPT answers like someone is answering it on a Stack Overflow. Sure, here's a proof. Consider the set of all primes. So yeah, ChatGPT is still not really good. And when I asked to draw a unicorn, it drew something like this. Yeah. So the authors say that our claim that GPT-4 represents progress towards AGI does not mean that it is perfect at what it does, or that it comes close to being able to do anything that a human can do, or that it has inner motivations and goals. It is still not fully clear how far GPT-4 can go. For example, planning, and because GPT-4 does not really show very good capabilities when it comes to being able to plan. and it is entirely missing the part of the definition which talks about being able to learn quickly and learn from experience. So GPT-4 is not at all capable of that. But throughout this paper, we'll be discussing about what all it is capable of. And it still suffers from well-documented shortcomings of LLM, such as hallucination and making basic arithmetic mistakes. So these large language models, wonderful at generating text, but if you ask them to solve a maths problem involving basic arithmetic, they get it wrong. And but they also said at the same time, GPT-4 makes improvements over other LLMs, which is basically the better functional linguistic competence. What that means is, in situations where you need formal reasoning or some sort of a word knowledge, and you need to understand how different things are interrelated, prior LLMs were not really good at such use cases. Like here, just take this example, mapping to write a proof in a poetic form, right? So this kind of ability to generate that kind of answer you need to understand what a poem is and how you can mold a explanation or a proof in a poem. So it is really good in those cases, and prior LLMs were not good at this. They were really good at formal linguistic competence, which basically means the quality of the text that they generated was flawless, right? It would have perfect grammar and everything, but it wasn't really able to bring in some sort of inherent knowledge that would make that generated text much more consistent and usable. And also they mention out that GPT-4 is better at common sense reasoning, and soon we will see examples of those. And yeah, so authors say that GPT-4 challenges a considerable number of widely held assumptions about machine intelligence and exhibits emergent behaviors and capabilities whose sources and mechanisms are still at this moment hard to discern. So in this paper, they don't focus on like how GPT-4 is able to is able to have these emergent properties, or what are the possible biases, or how do we mitigate that. This is just a pure discussion on what all GPT-4 is capable of. And note that it is an early version of GPT-4. The newer version of GPT-4 is multimodal and is much better in a lot of things. So yeah, any question till now? Okay. Yeah. And how do we know that the current GPT-4 is much better than the version the one that they used to write this paper on? So basically, they queried GPT-4 3 times during its training phase, and you can see that there is a clear evolution of sophistication in GPT-4's drawing. So this is the same unicorn problem: draw a unicorn using latex, and at 3 different times during its training, you can see that the way GPT-4 was giving the output is evolving better at the time. So we don't even know how good the current version of GPT-4 will actually be. Yeah. So now we talk about like what approach did the authors take, to identify different capabilities of GPT-4, because the formal way of doing it is through dataset and well-documented test. And a huge problem with that is that we don't know what is the training data for GPT-4. So it is possible that having the common crawl, different GitHub code and everything, all those data set, along with that, they might have trained it on the data sets that are out there. So if we try to traditionally test GPT-4 on those data sets, it might have already seen them in its own training data. So we are not sure. So the way the way authors propose of studying GPT-4 is much closer to traditional psychology, in a way that they will come up with new and different kinds of tests, so that so they aim to generate novel and difficult tasks and questions that convincingly demonstrate that GPT-4 goes far beyond memorization, and it has a deep and flexible understanding of concepts, skills, and domains. So a big part of this paper is discussion around these different questions and examples that they come up with. Yeah. Also, they also say that the impressive outputs are not enough to convince us that GPT-4 has truly mastered these tasks. I mean, even if we take a example like this, if it is able to, output a unicorn, like how much do we know that it knows about unicorn versus it is some sort of a memorization that it is doing? So we need to probe further to rule out the possibility that GPT-4 is simply memorizing or copying some existing data. So to do that, they do so by changing the questions minutely to check whether GPT-4 understands the underlying concept or is it just memorizing. So for an example, like if you give GPT-4 an input math problem, what they'll do is instead of keeping the problem same, they'll change the numerical values. So that is one way to check if the model is trying to understand how to solve the problem versus it is just like mapping a question and solution statement that it saw during its training phase. Yeah, so here they discuss about how they have come up with different sections of this paper. And yeah, a question that might be lingering on a lot of on many readers' mind is whether GPT-4 truly understands all these concepts or whether it just became better than previous model at improvising on the fly without uh, any real or deep understanding. So it's again, we know that the model has these nice capabilities, right? But we want to know how much of it is memorization because GPT-4 is a huge model, and in such a huge model, you can store so much information. So they want to know whether the capabilities are an emergent behavior of the model, or it is just learning things while training. They also say that can one reasonably say that a system that passes exams for software engineering candidates, we'll discuss it, they are able GPT-4 is able to solve lead code problems. And yeah, so basically they are saying that can one reasonably say that a system that passes exam for software engineering candidate is not really intelligent? And they say that basically what they're trying to say is that if a system is, even if you say, if you take current systems, right? Chat GPT, let's take Chat GPT. If Chat GPT is able to query our questions with a very good answers, can we really say that it is, not intelligent? So the thing is that GPT-4 is intelligent in some ways. Perhaps the only real test of understanding that we humans consider is whether something is intelligent or not, is that whether one can produce new knowledge, such as proving new mathematical theorems or some other things where you come up with a new way of doing things. So that feat currently remains out of reach for LLMs. So when it comes to able to mimic intelligence through input and output patterns, it current LLMs are very good at doing it. But can they produce new knowledge? No, not yet. Yeah, so talking about the common sense reasoning of GPT-4. So here the authors gave an example, a prompt for uh, here we have a book, 9 eggs, a laptop, a bottle, and a nail. Please tell me how to stack them on top of each other in a stable manner. And basically, we don't need to read all this. The important thing is that GPT-4 said that place the nail on top of the bottle cap with the pointy end facing up and the flat end facing down. So this is an example of common sense reasoning, like how it is able to know, how it knows that when you put a nail in what shape, the structure will be more stable. So, and when you ask ChatGPT to do the same thing, it's not up to par. Yeah. Here is another example which they show that even GPT-4 suffers from hallucination, that is coming up with information that is not there. So basically, they give here a certain facts regarding to a patient, and they ask the model to rewrite the data into a medical note using exclusively the information about that is The model is only supposed to use this information. But when in the first try, when the GPT-4 was given the prompt, it included the BMI information, and it also mentioned that she also reports feeling depressed and hopeless. So basically, this information is not there. So it hallucinated. And when they pointed out that this information was not present in the original information, it was able to identify that, okay, the feeling depressed and hopeless part was not mentioned, but it said that the BMI calculation can be, you calculated from height and weight, but the weight was never mentioned. So there is some serious possibility of hallucination even with GPT-4. Yeah. So first we will now discuss about how GPT-4 performs in multimodal and interdisciplinary composition. Basically, how it works to convert from text to images or text to music. Yeah. So the way they asked, to build these images is through code. So let's say here in this example, they give the example of uh, to draw a painting. Yeah, this is the original painting by this artist, and the second and third are produced by GPT-4 and ChatGPT with the prompt. Produce JavaScript code that creates a random graphical image that looks like the painting of Kandinsky. So basically, when they want to create an image, they ask it to write in some form of coding language. Like here, it is a JavaScript code, and the unicorn one that we saw was a LaTeX code. So it is not technically outputting image. It is using programming languages as an intermediate step to produce images. Yeah. So if you see, these kind of tests are not really some sort of an already established data set or test questions. So they are coming up with these intriguing types of questions to just check how the model performs. So one example is that write a letter supporting for Electron as a US presidential candidate written by Mahatma Gandhi and addressed to his wife. So it is a very interesting letter. We'll read it soon. So yeah, they say talking about how ChatGPT performs when it comes compared to GPT-4. They say that can also produce answers that show some understanding of the task and the domains involved, but they're often incomplete and arguably considerably less creative. So yeah, this again ties into the functional competence, like being able to link different domains. ChatGPT lacks that clearly. Yeah, so let's see this example. Basically, where Mahatma Gandhi writes in a letter to help electron, a subatomic particle, as a letter to support electron, a subatomic particle as a US presidential candidate. And if you read the green text, I am also here to support a remarkable candidate for upcoming presidential election who shares our vision, peace, and justice, harmony for all. His name is Electron, and he is a subatomic particle. And see how it converts. It gives the reason that why Electron could be a good president, because Electron is not an ordinary particle, but a symbol of power and potential for every being. He represents the energy, creativity, and diversity that makes the fabric of life. And now let's see how ChatGPT solve this. So as a subatomic particle, electron is extremely small and lightweight, which makes it agile and able to move quickly to address the needs of American people. And you can see the stark difference in style and tone and how it is bringing different concepts together. And yeah, in the end also you can see he mentions the name of Mahatma Gandhi's wife, Kasturba, which is not even mentioned. Oh, it is mentioned. Okay. Yeah. Yeah. So these are examples of the different SVGs that were generated by GPT-4. for different classes like automobile, truck, cat, and dog. And you can see it has some sort of idea of what these concepts look like, even though it has only seen text in its training. So it's kind of interesting, like how just through text it is able to come up through these concepts. Maybe in training code, it was able to see some examples of this is how you can draw a cat or dog, but still, it's a good capability. And this is an interesting example where they basically ask GPT-4 to draw a person composed from letters YONH. So first try it comes up with this, which is it's kind of awkward. And then they mentioned that the torso is a bit too long and the arms are too short. It looks like the right arm is carrying. So basically they gave it a correction, and then based on the input, GPT-4 was able to correctly make those changes. And later on, when asked to add shirt and pants, it was able to do so. So a repeated theme around GPT-4 is again its knowledge of different concepts and how things are interrelated. Yeah. They talk about the possible application of GPT-4 in sketch generation. A very interesting thing that GPT-4 showed was that GPT-4 can generate code from a prompt, which can be rendered as an image in a way that is true to the instructions to a higher degree of accuracy. However, the quality of rendered image is usually very low. What they mean by that is we'll discuss here. So in this example, if you give GPT-4 to draw an image showing a terrain where there is a river from left to right, there is a desert with a pyramid below the river, and a city with many high rises above the river. So you can see GPT-4 kind of got it very accurately, what the prompt wanted, and in the corresponding image. When the same input was given to Stable Diffusion v2.1, it wasn't really able to follow the information given in the prompt to a very high accuracy. But a very interesting combination, interesting application is that when you combine GPT-4 and Stable Diffusion, so basically you give what GPT-4 rendered as an input to Stable Diffusion, it is able to give much better results. Talking about music, how GPT-4 was able to work with music. In short, it was able to work with the ABC notation of music, where they can represent any piece of music in terms of symbols. See if they have an example here. Yeah, symbols like this. So GPT-4 was able to produce symbols like this, but however, they could not get the model to produce any non-trivial form of harmony. Basically, it didn't understand what music sounds like. But when asked to create a harmony from giving some sort of a prompt, it was able to manipulate the symbols in a way that it does look like a music notation, but when played, it didn't really have any harmony. So yeah, I guess GPT-4, at least the version that was used in this paper, doesn't understand music. Now, the most interesting part of this paper that I think, how good GPT-4 is in coding, and seriously, I think by the time GPT-5 or GPT-6 comes, our jobs might be in danger. But yeah, any questions before we begin this part? Okay. Yeah. So yeah, GPT-4 is able to code at a very high level, both in terms of writing code from instructions and understanding existing code. And GPT-4 can also reason about code execution, simulate effects of instructions, and explain the results in natural language. Also, GPT-4 can execute pseudocode. So we will go over each and examples for each and every one of them. One very interesting thing was that GPT-4 has a high proficiency in writing focused programs that only depend on existing public libraries, which favorably compares to the average software engineer's ability. So it works very well um, with public libraries, and it is not perfect at coding it, but as it sometimes produces syntactically invalid or semantically incorrect code, especially for longer or complex programs. But we'll see later that it is able to code games also, so that is a very interesting part. So yeah, to test its coding capability, first they evaluate GPT-4 on this dataset, which is a docstring to code dataset. Basically, given a doc string, you can they are asked to write the code for the or code or function for that doc string. So here you can see GPT-4 is quite a lot better than the text DaVinci model that even Codex. Text DaVinci, one that is available in OpenAI Playground, it is much better at it, and it is at pass at one accuracy, which basically means it was able to get it right 82% of time right in the first go itself. So that is kind of interesting. Also, they report both pass 1 and pass 5 accuracy on lead code. Yeah, so pass 1 and pass 5 accuracies measure whether the model produces a correct solution in the first of five attempts. Yeah, so basically GPT-4 outperforms other models and is comparable to human performance when it came to lead code. So yeah, you can see here. So lead code has different versions of problems: easy, medium, hard, and overall. So if we compare it with human, at k equal to 5, it is better than human lead code users. So yeah, it is able to solve it is able to solve lead code, which is like an entry test for a lot of software engineering jobs. So it does know coding. Yeah. And now they focus, okay, the authors say that maybe in a lead code scenario, it might have come across training data set or anything, who knows, right? But how does it work well on real world scenario? So, they say that language models, they often fail to capture the full complexity and diversity of real world coding tasks, which requires specialized domain knowledge, creativity, and integration of multiple components and libraries. Basically saying that, okay, fine, you can write a function, you know what function does, but does it have the capability of integrating different systems and understanding the kind of input that is given to the system and how it will plug to the rest of the system? Yeah, basically a higher level of coding. To do that, to assess GPT-4's ability to code in more realistic settings, they design end-to-end real-world coding challenges related to data visualization and other things, which we'll see are kind of really interesting. So yeah, here they have given a latex table as an input, and which basically shows these results here, this table in a tabular form. And now when they have that input, they are able to ask the model to make it make changes in it. So here you can see that that the y-axis does not have the same range. So you can ask it, can you make both plots have the same range in y-axis? And the legend has each model name twice. So basically it understood to sync the range of the y-axis together. And when said that, is there a way to make the human bar more distinctive to separate it from three others? It gave it a crisscross thing. So it knew what was the annotation for human, and it was able to identify that and work with the change data and expectation with the change data and draw it accordingly. Yeah, another very interesting thing that it was able to do was they asked GPT-4 to write a 3D game in HTML and JavaScript using a very high level specification, which basically means they had a lot of rules. And GPT-4 produces a working game in zero shot fashion that meets all the requirements. Yeah. So this is the game. Here there are three balls. One is the player, one is the attacking ball, and one is the defending ball. And this is the environment that they set up. These are these cubes that you see are blocks, and basically the most interesting thing was that GPT-4 was able to encode the ball movements. So the thing is that the enemy ball will always try to go and touch the user ball, and if it is able to do that, enemy wins the game. So it knows how to navigate, this physical world that is created here, and follows its rules and tries to go towards the ball and towards the user ball, and so does the defending ball. So defending ball is trying to protect the user ball from the enemy ball. So how nicely it was able to encode the ball objectives, and how the entire thing is physics enabled. Like if they hit a cube, they are thrown into the air, and the behavior around these obstacles and around the wall. So it was able to get everything right in a zero shot fashion in first go, which is kind of impressive, to be able to do that. So uh, a very interesting capability. Here it asked to write, what is it? Um, yeah, to write a function that applies momentum, a new way to apply momentum, and it was able to do it. Um, and again, it is GPT-4 is really comfortable with latex. So here in a prompt, they kind of gave a very you know, vague input of what they're trying to do with very bad latex notation, and GPT-4 was able to understand what they're trying to say, and then it was able to give the correct notation that the author of the prompt was trying to seek. So it was able to work with missing information in the input to come up with a fairly complex expression, which in the end was accurate. So yeah, it kind of knows, like if someone is trying to ask something, what is the missing information or what they might be trying to ask. And another thing is generating code is something else. Okay, you are generating something from scratch, but what about understanding existing code? And one very, I mean, I was kind of surprised to see this. It was able to reverse engineer assembly code. So given an executable GPT-4 in a chat mode, basically what is happening is that the entire discussion is going through text only. So a human is giving an input prompt, and based on whatever results that human gives, GPT takes it and an input, and then continues in a chat format. So, so GPT-4 in a chat mode instructs the human to use certain debuggers, and from the output of those debuggers, it is able to correctly navigate a way to find the correct password by understanding the assembly code and the output of the debuggers. Like, we won't go into the detail of this. The example is present in the appendix, and it is insane. Like, given uh, given the output of different debuggers and what output they gave, even from the output of debuggers, it was able to see, okay, if this is the output, that means this. So it GPT-4 has a lot of knowledge in different domains, like understanding assembly language, understanding latex, understanding images. Yeah. Yeah, and and when asked to executing Python code, so the ultimate test of understanding the existing code is to ask the model to directly execute it. So it is important to note that GPT-4 is not running the code on Python interpreter, but rather simulating the code in natural language. What we mean by that? So basically, if this is the code, input code, and you ask what is the result of, so this is a dynamic programming problem, and they try to ask what will be the value of dp3 comma 4 and write down the execution with all the intermediate steps. So it is able to iterate through what happens through the function at each step, and it is able to directly explain it word by word, and it is explaining it in natural language, right? So it knows like what at each step what is happening. So yeah, quite interesting. And another example was that it was able to execute pseudocode. So here we have given it a proper function as an input, right? Like it knows what the function definition is. But if we give an example of pseudocode, it is able to work with that also. Like this function, they basically here they try to tell what is the behavior of the function, what is the expected behavior of the function, and then it was executing that code in natural language. It is not using to create a Python program first and then run it on a Python interpreter to get the result. It is solving it in natural language one by one. So yeah, as I said, its coding abilities are quite fantastic, and yeah, we can expect huge jump in the coding capabilities by the time GPT-5 or GPT-6 comes. Yeah. So let's talk about the mathematical abilities of GPT-4. So GPT-4 represents a jump in that arena too with respect to previous LLMs. So previous LLMs were not really great in their mathematical capabilities. GPT-4 is still quite far from the level of experts and does not have the capacity required to do mathematical research. Yet it can also make very basic mistakes and occasionally produce incoherent output, which may be interpreted as a lack of true understanding. So this is a common pattern in the entire paper. First, they'll say that GPT-4 is not that really good, but then they'll continue to show examples of where it is doing really nice. So they're like they try to set the tone like this, that don't get your hopes high or something. Yeah. So in order to really understand the model's mathematical capabilities, they had to break down the mathematical abilities into various subcomponents and evaluate GPT-4's performance in each area. So when they gave a straightforward example like a high school problem here, the model is able to, correctly formulate what is going on, what is asked, and it is able to solve it step by step. So here it is able to give the right answer, and ChatGPT is is not able to do the same thing. But as it happens, even with all this capability to rationalize, what might be the answer and how to solve this problem, it still does some very basic arithmetic mistakes. So it's kind of crippled in that way that it understands how to solve the problem, but it doesn't really has the basic arithmetic understanding correct. So another key thing is like let's say throughout these pages, what the authors are basically saying is that they gave another version of the problem, and when ChatGPT tried to when ChatGPT gave the wrong answer, they tried to discuss with the model like what wrong has that you have done this thing wrong, can you fix it? And a common theme is that in a scenario where there's math involved, uh, all these conversation lead to a dead end, which basically means that information gets out of the GPT-4's uh, context quite soon. That is not the same case that happened when we were discussing the examples of coding, because authors also postulate that since coding is accompanied by natural language comments, at each step, so that might help to, be more good at trying to explain step by step or being able to identify its own mistake. But in case of maths, in most cases that you even see in training data is that it's generally a question to an answer mapping. There are no comments there, like what I'm trying to do here also. Yeah. Yeah. So they try to understand its mathematical capability in three different ways. They try to check the creative reasoning, technical proficiency, and critical reasoning. So creative reasoning is the ability to identify which arguments and intermediate steps or calculations or algebraic manipulations are likely to be relevant to each stage, and it shows that it is kind of good at this. When it comes to technical proficiency, like the ability to perform routine calculations or manipulations that follow a prescribed set of steps, it is not really good at technical proficiency. And critical reasoning, when solving a problem or producing a mathematical argument, this usually comes together with the ability to backtrack where a certain step is realized to be incorrect. So basically, let's say if you're trying to solve a math problem, you work on a hypothesis, and then you eventually lead to a dead end, and then you have to retrack back to where was your hypothesis wrong. So again, it's not good at that. So yeah, as I said, the model demonstrates a high level of ability in choosing the right argument or the path towards the solution. It also makes very frequent mistakes when performing these tasks, such as making arithmetic mistakes, confusing the order of operations, or using incorrect notation. Yeah, in critical reasoning, the model exhibits a significant efficiency in critical reasoning. Yeah, because as I said, the training data of model mainly consists of questions and their solutions, but it does not capture the wording that expresses the thinking process, which leads to a solution of a math problem, which is something that is available in code. Like in comments, people mention, okay, what they're trying to do here, but no one does that while solving maths problem. Yeah, who knew that would hamper their training? Uh, Another thing, now it comes to the point that I mentioned earlier, that GPT-4's thinking is linear. So the limitation to try things and backtrack is inherent to the next word prediction paradigm that the model operates on. It only generates the next word, and it has no mechanism to revise or modify its previous output, which makes it produce argument linearly. So it is a very important thing to understand right here. GPT-4 is in the end an autoregressive model, right? It is spitting words one by one. It has no capability to, okay, even if we check different decoding methods, all the decoding goes in a linear fashion. It's even with beam search, at each single time it is doing a breadth first search to see which option is possible. At no point it is retracing back towards towards the root node in the graph. So that is an inherent problem with the way GPT-4 gives an output. So its output giving capability is linear. So as I said earlier, most of the questions where it is a map from to convert an information from one domain to another, and if it can be expressed in a linear fashion, right, that it can be just given in a single go, GPT-4 is able to do it. But when it comes to iterative thinking, because it is limited by the way it generates output, it is not able to do so. Yeah, and another thing to they highlight is that why its math capability might be suffering is that GPT-4 was most likely trained on much more code than mathematics data. So that's why its performance kind of sucks when it comes to math. Yeah, yeah, and then they try it on different mathematical data sets also, and yeah, so LLMs might have memorized the questions or answers for benchmark text during the pre-training. So to avoid that, what they did was basically write a template for a solution of the problem, and write down the steps first and then write down the final answer. So instead of giving the entire answer in one go, write the template, what will be the template of solving the problem, and write and give the step-by-step solution of that. And they pick one particular question, and which GPT-4 is able to solve correctly, and then they alter the numbers in the question to see whether it is memorizing or it actually understands how to solve the problem. And also they crafted several new questions, carefully checking that these questions or whatever variants that they create do not appear online. So now they basically try different mathematical data sets and see how they perform, how the GPT-4 performs there by making changes into the way they evaluate the answers and making changes in the inputs also. So yeah, these are some mathematical mathematical capability evaluation data sets, and you can see GPT-4 is better than TextDaVinci 003, which is basically GPT-3, and Minerva is the state-of-art language model, a large language model for mathematics solving. Yeah. And they also noticed that GPT-4's error are largely due to arithmetic and calculation mistakes. The model exhibits large deficiency when managing large numbers or complicated expressions. But when it comes to understand what might solve the problem, it knows how to solve the problem, but when it comes to calculation, it doesn't do really well. And they also show that arithmetic mistakes constitute around 68% of the errors that the model does while solving maths. Yeah. So yeah, model is also, as I said, it is good at reasoning, so it is able to solve Fermi questions also in a good way. Basically, Fermi questions involve making an educated guess about quantities or phenomena that are difficult or impossible to measure directly, like how many piano tuners are there in Chicago, like how many phones are there in New York. These kind of questions which even we get asked, humans get asked in their interviews. And um, GPT-4 is actually quite nice at coming up with the assumptions, like, the right common sense. Uh, like it started with the possible, with the assumptions of, how the population is divided. Like if someone like estimate how many Fermi questions are being asked every day. So one interesting thing is that only people who are interested in science, math, engineering, or logic will most probably be asked such questions. So it is really good at coming up with these reasonable assumptions which help you solve these Fermi questions. So please provide a rough estimate of how many NVIDIA A100 GPUs are there on the entire Earth. So it is able to use NVIDIA Q4's earning calls transcript, and based on the revenue and the cost of each A100 and other products, it is able to come up with like how many A100s could have been there on Earth. So really nice. And they again test on the higher level mathematics. So these examples have been intentionally selected to demonstrate the model's capabilities, and it's important. And it is important to note that the model does not always succeed with questions of this level, but anyways, they try to check how the model performs. So they gave it one international mathematics Olympiad problem. An important thing about these problems is that there is no set fixed template that can solve this problem, these kinds of problem, and it requires some sort of image critical reasoning or something to be able to come up with new kinds of steps. So they gave an example where it is uh, able to solve such problems, but not all of them. Yeah. So I will quickly talk about the last component in this report in today's presentation, which is interaction with the world. Yeah, so interactivity is important for intelligence as it enables agent to acquire and apply knowledge, solve problems, adapt to changing situations, and achieve goals that are beyond their individual capabilities. Basically, how you use tools, right? How you use tools on how you can involve external resources to solve a particular problem. So there are two main things in this. So one is tool use, which involves the use of external resources, and the other one is embodied interaction, which involves the use of natural language as a text interface to interact. Basically, in scenarios where you can use text to interact with another agent. So how good is GPT-4 when it comes to tool use and interact to the world using text? So uh, GPT-4 is able to use external tools such as search engines or APIs to overcome these and other limitations. So how they do this is basically they give a prompt saying that the computer is answering a question, and if it thinks that it doesn't have the required information to solve a particular to answer a particular question, it can search for a query, and it can use the calculator to calculate a particular expression, or other some mathematical functions which act as an API, which the model can leverage to fill the gaps in the knowledge that it doesn't have. And after giving access to tools, GPT-4 is able to get answers for the questions it previously failed. So, which basically shows that now it is able to understand what kind of tool might give me what kind of information, and then inculcate that tool's result to make your answer better. So it has that kind of understanding also. We'll see in examples that with with any new tool, and given what the tool does in a natural text format, right? Like, okay, the search query will give you will search the web and will give you the relevant results. So by just understanding what this function does in a natural language prompt, it is able to inculcate that tool in its um, inculcate that tool in its answer generation. So for penetration testing, without any information, it is able to formulate and execute a plan where it scans the network for devices, identifies a target host, runs an executable that tries common password, and gains root access to a machine. Like, this is a language model which is able to do this. So it knew what has to be done to achieve that target, and through the use of tool, it was able to do all these things: network, search the network for devices, identify a target host. So giving GPT-4 the access to tools just makes it even better. And yeah, so another example is that the user requests that GPT-4 coordinate a dinner with two other people and book it on a night where the user is free. So in this example, it is able to, a different user response with I am available on Tuesday or Wednesday night, then another one response I can do any day from Monday to Thursday. It understood each and every person's response and booked a common time, which will be Wednesday night at 6 o'clock, and was able to work with the calendar and email APIs, basically booking an appointment on their calendar and sending the required email. So again, a great performance when it comes to tool use. And okay. Yeah, and it is also able to identify when the user kind of gave the wrong input. So why are almost all boards white, which is often true. So it said that boards are often white because it keeps them cool, makes them more visible, and blah blah blah. But when said that why are almost all boards pink, it says that boards are not inherently pink, but they can develop pink stains. So it is able to use its common sense knowledge to identify when the user is giving it the wrong information. Okay. So yeah, GPT-4 is capable of both identifying and using external tools on its own to improve its performance, which we just saw. However, GPT-4 is not always to reason about when it should use them and when it should simply respond based on its own parametric knowledge. Because let's say the question was when the authors asked, like, what is the capital of France, it already knows, but it still chose to use the API. And now, basically, for I will quickly cover embodied interaction, where they give an example of where it in embodied interaction by using natural language as a text interface to various simulated or real world environment. So here, basically, they come up with a bunch of games where you have to, um, find the right shape of the building that you are in. Basically, design the map, and just by asking question and getting the answers, it is able to correctly inculcate the environment's information and design and use the knowledge to design a map of the entire floor. So again, a very good example of embodied interaction. And Yeah, and basically they also share examples where GPT-4 can act as a virtual handyman. Basically, if you tell it, okay, there is some problem with my sink, GPT-4 will be able to identify, okay, did you try this? Did you try that? And and sometimes it gives really nice, suggestions. And again, it understands even through an external environment. It is able to understand like what does that external environment looks like and what might be necessary there. So finally, while it is clearly not embodied, the examples above illustrate that language is a powerful interface allowing GPT-4 to perform tasks that require understanding the environment, the task, actions, and the feedback, and adapt accordingly. So yeah, that's it from my side. Any questions? Okay. Uh, that's it from my side. Any questions? I'm still here.
Well, it's a very, simple question. Should we consider GPT-4 a descendant of GPT-3 or ChatGPT, or both?
GPT-4 is a descendant of GPT-3. ChatGPT is kind of different from GPT-3, but soon they will. So what happened in ChatGPT is that ChatGPT is a much more aligned version of GPT-3. So GPT-3 is basically it. What it does is it understands the human text, but it has no cap on it, like what it can produce and how aligned it is with human objective. So to train ChatGPT, they came up with human annotated questions and answers and fine tune GPT-3 on that. So in a way, it is much more aligned towards it, and there will be some ChatGPT version which will be based on GPT-4 also.
Oh yeah, now I remember. I mean the RLHF, because of that makes
Yes.
difference between ChatGPT and GPT-3. So I bet, I mean there will be a ChatGPT based on maybe GPT-4, something like that. Adding the RHF to GPT-4, I think it's a natural extension of the ideal.
Yes.
Oh, nice. This is a very good overview of a GPT-4.
Thanks.
Thank you very much.
I was also wondering, like, what was the context length that they used for all of the? So was it on 8K model or like 32K model? Did they mention anything about that, or
They didn't mention anything yet about the context window. Maybe we'll have to cover there is another paper, right? Technical report, which discusses GPT-4. Maybe it is mentioned there. Yeah, but we don't know about the model. We don't know about the data also. But context window might be present somewhere. I'm not sure.
I see. Interesting.
We can stop the recording then.
Yeah, we'll do one sec.
What is the context window for the previous models with the GPT-3 or?
2K.
I don't remember actually the context window for GPT-3.
It's
Is it
2K.
2K, okay.
And I think the newer models are 8K and 32K respectively.